Consider three charges Q1, Q2, Q3, each equal to Q, are the vertices of an equilateral triangle of side A. What is the force on a charge Q placed at the centroid of the triangle? So, if O is the centroid of the triangle, at the centroid we are placing a charge Q. A, B, C are the vertices of an equilateral triangle. So the sides of the equilateral triangle are taken as A. Now, AD is a perpendicular line. Now, O is the midpoint, that is the centroid of the triangle. Here, Q1 is equal to Q, Q2 is equal to Q, Q3 is equal to Q. Three charges placed at the vertices of the triangle. Now, if we take the triangle BAD, we know that the angle of an equilateral triangle is 60 degree. Since we have taken off of this triangle, this angle will be equal to 30 degree. So in the triangle BAD, we know that adjacent by hypotenuse is equal to cos 30 degree. And what is cos 30? Cos 30 is root 3 by 2. Okay. So adjacent by hypotenuse is cos 30 degree. Here the adjacent side is AD and hypotenuse is AB. So AD by AB is equal to cos 30 degree. AD is equal to AB. Cos 30 value is root 3 by 2. Since AB is equal to the side A, so A into root 3 by 2 is the value of AD. Here in the diagram, AO is nothing but 2/3 of AD. So AO is also equal to 2/3 of A root 3 by 2, which is nothing but A by root 3, because 3 can be written as root 3 into root 3. One root 3 from here and another root 3 from here will be cancelling, and 2 will get cancelled. So we get A by root 3. We are going to find out the force F1, F2, F3. So these are the three forces acting on the charge Q, which is placed at the centroid O. Here F1 is a force acting on the charge Q due to Q1. F3 is a force acting on the charge Q due to Q3. F2 is a force acting on the charge Q due to Q2. Now, what is F1? So, F1 is equal to 1 by 4 pi epsilon naught, capital Q into small q. Capital Q into small q. In place of r squared, we are using the distance AO squared. Here AO squared we have measured A by root 3 the whole squared. So we get F1 is equal to 1 by 4 pi epsilon naught 3 into QQ by A squared, which is acting along AO. In vector form, F1 vector can be written as 1 by 4 pi epsilon naught 3 into QQ by A squared into r cap, where r cap in this diagram it is not shown, but r cap is a unit vector acting along OA. Similarly, we are finding out the F2, which is equal to 1 by 4 pi epsilon naught 3 QQ so by A squared, which is acting along BO. Again, similarly, F3 is measured 1 by 4 pi epsilon naught 3 QQ by A squared along CO. Now, we are going to find out the net force here as shown in the diagram, net force F on F2 and F3. So that is taken as capital F vector, which is nothing but 1 by 4 pi epsilon naught 3 into QQ by A squared into r cap. Since it is a vector form, r cap is given. Now, the vector form of F1, as we have discussed earlier, is equal to 1 by 4 pi epsilon naught 3 QQ by A squared into r cap. Here in this diagram, This resultant force F and the force F1 both are equal in magnitude, but they are acting in the opposite direction. So the total force F suffix t vector on the charge Q is F suffix t vector is equal to F minus F1, which is nothing but 1 by 4 pi epsilon naught 3q by a square r cap minus r cap, which is equal to 0. I think you have understood. Thank you.